What is up, you guys? Welcome to another video on the Dusk Show. In today's video, we will be learning how to do partial derivatives. Now, in order to do these, you need to have a basic understanding of derivatives and the derivative rules. But if you have that, these are really not bad at all. And they can look kind of difficult. But if you know how to do derivatives, then the concept comes very easily. So here's our function. F of xy equals xy plus 2x squared plus 4y squared plus 1. And in a function with two variables like this, you're going to have two initial partial variables, f with respect to x and f with respect to y. And when I say with respect to, I mean you consider that to be a variable, the x, in respect to f of x, and you consider the y to be a constant. Right? So if you know derivative rules, it's almost like y is a number here. So in order to do f with respect to x, the derivative of xy would end up just being a y, right? Almost like it was like 9x. Plus 2x, you're going to end up with 4x. Plus 4y squared, that goes away, right? It's just like it's a number, goes away. Plus 1, that goes away. So this is our partial derivative with respect to x. Now let's do y. xy, you're going to end up with just an x plus 2x squared. That completely goes away. Plus 4y squared plus 8y. Plus 1 goes away. And these are our first initial partial derivatives. Not too bad, right? And for a lot of things, a lot of applications, you're going to want to take second partial derivatives too. And so in a function with two variables, you're going to end up with 4 second partial derivatives. F of xx, f of yy, f of xy, and f of yx. Right? They're pretty much exactly what we have done already. I'm sure you can infer what we do to get them, but let's go ahead and solve them out and show. So f of xx means you take the partial derivative of f of x and derive it again with respect to x. So if you do that, the y would go away. Let me go ahead and section these off really quick. The y here goes away. 4x would turn into 4. And that's it. F of yy, we have the y here, derive it with respect to y, and all you have is 8. Because the x goes away, and this becomes an 8. Now f of xy, y plus 4x, that you would just end up with a 1. Right? Because the y turns into the 1, the 4x goes away. F of yx, the x turns into a 1. 8y goes away because we're integrating with respect to x. And these here are our second partial derivatives. And generally, second partial derivatives will take you to pretty much everything you need to know. This is essentially mostly what you would need for applications in Cal 3 at least. And really not too bad, as you can see. One thing to note here is that f of xy and f of yx are the same. And you might think, wow, that's a cool coincidence. But I can say in most situations, in like a smooth curve, the same parameterization, they are going to be the same. Right? It is, if they're the same, it's a very, very good sign that you're doing things right. So it's something to at least keep in mind, something that you might want to point, something you might want to check out. For most of the time, they will end up being the same. Anyways, I hope this video was helpful in learning how to do partial derivatives. If you have any questions about how to do it, don't be afraid to leave a comment. I'll try and explain more. And if you have any suggestions on videos to make next, go ahead and ask. I'll make them. I can do most math concepts that are in the calculus field or discrete mathematics or something like that. Anyway, thanks for watching and good luck in your studies.